dear students.
We will discuss about high level data link control, HDLC. Okay, so high level data link control is a bit oriented protocol for communications over point to point and multi point links. Here you can also do this point to point. We can apply this algorithm point to point as well as we can apply it for multi-point connections also, and it implements the ARQ mechanisms, okay, what we have discussed already. So here we will discuss about configurations and transfer modes, frames and control field. Okay, so these are the different operations, the different topics we need to discuss here. So at first, this is the normal response mode. See, there is a point to point. হ্যাঁ বলো, কে বলছো? কিছু শোনা যাচ্ছে না তো তোমার কথা। কে বলছো? হ্যাঁ বলো। আচ্ছা, আমি না কিছু শুনতে পাচ্ছি না, তুমি করো একবার, তোমার সাউন্ডটা আমি একদম আসছে না, পুরো ব্রেক করে যাচ্ছে, লিখে দাও তো চ্যাট বক্সে। Okay, so this is a normal response mode. Here you can see we have a primary station, and primary station can send the comments to a secondary stations, and the secondary station can only respond it. Okay, so only primary station can send the comments to the secondary stations, and secondary stations only can't provide any response. Okay, so this is you can say that NRM or normal response mode, and here this NRM is used for both point to point as well as multi point connections. So this is point to point for NRM, and this is for multi point connections. Okay, so here we have a primary connections, and we have different secondary machines, secondary host machines are there, and the data can be passed from the command can be passed from the primary stations to the different secondary stations. Okay, so now this is the asynchronous balance mode. So this asynchronous balance mode, that means it can configure, this is the configurations mode, and this link is used also for point to point connections, and here also each station can functions as a primary as well as secondary stations. Okay, so the previous method you can see that the primary stations is a single stations which can send the comments, and the secondary stations can send only the response. But here in asynchronous balance mode we have combinations of command and response both. Each and every machine can send the command as well as they can provide the response also. Okay, so here in this link, this link is point to point, and each station can functions as primary as well as secondary. Okay, now this is the HDLC frame. So HDLC frame format is important. Here you can see that we have different types of frame. So here we have I frame, we have I frame, S frame and U frame. Okay, so I frame, S frame and U frame. So I frame is the information frames, this is the information frame. And S frame is the supervisory frame. Supervise it do any, if there is any supervisions is going on, so this frame is responsible for that. Supervisory frame, and this is U frame, this is unnumbered frames. So this is unnumbered frames. Okay, so these three types of frames HDLC frame is HDLC frames have these different types of frames. So here you can see for I frame, each and every frame has the flag value. There is a flag at the starting point and flag at the end of the frame for each and every frame. And now the address is here. For that address means what? Each and every frame should hold the address of sender as well as the receiver. So addresses is here, and as well as the control informations. Okay, so control, this is the control. Control is this field holds the control informations, and it relates to user data. Okay, and that is the actually PG backing. Control informations means here I am sending the frame, the sender is sending a frame as well as the sequence number, and the and sequence number obviously is there, as well as the frame number and the next frame what it needs to send, that should be there. So PG backing is going on here. Okay, so this is the control informations. The control field is responsible for that, and this is iframe. So user informations is here. Okay, so user informations can be here. So, and for supervisory frame we have this, here we don't have any different types of user informations, but only iframe can hold the user informations, but supervisory frame don't have this super user informations. Okay, it only has this FCM. Okay, so FCS, that is for frame check sequence. Okay, this is for frame check sequence. So this FCM field is here. So FCS field is here. So here also in iframe we have this FCS field, and here also we have the FCS field. So each and every frame can hold these things, that is flag, address, control, FCS and flag. These 5 fields are common to for each and every frame, but this things, that is the user information, this field is only for iframe, and management information, this frame is only for uframe. Okay, so now you have to know the details of each and every field. So what is the responsibility of this flag field? Flag fields, what this field can do? So flag field of an Hdlc frame is an 8-bit sequence. Okay, so we have 8-bit only, we have 8-bit sequence, and here the bit pattern, what we already studied, that bit pattern can be 0, and we have 6 ones, and after that we have a 0. So this is the flag field. Okay, so this is a 8-bit sequence, and the sequence is this. Okay, and you have to fix the sequence. That means when this sequence is so when you have the sequence, suppose we have our data, and if we have this informations inside our data also, then we need to do bit stuffing or character stuffing there to discriminate the data from the flag. Okay, because this flag is fixed 0, 6 ones and 0, this is the flag value, and that means it indicates the delimiter, that is it indicates the starting of a frame, and the end flag also indicates the end of the frame. Okay, so this is called delimiter. Okay, and when any data can hold this type of bits, then we need to add some extra bit inside that, that is called bit stuffing. And if you want to add some character here, that is called character stuffing, to discriminate flag from the bit from the data. Okay, so this is the flag field, and here it can identify both for beginning and for the end frame, right. So now we have address field. So address field is what? So this field is also very important, because and it can be also 1 byte, that means 8-bit. Okay, it can be 8 bits, or address can be long also, more than 8 bits it can hold. So here in this field it can hold the address of sender as well as receiver. Okay, so both addresses can be stored here. Now there is another field, that is control field. So this control field can be 1 byte or it can be 2 byte. Control field can be 1 byte or 2 byte segment of the frame, and it is used for flow control and error control. Okay. This is used for flow control and error control. Okay, so this is the control field, and so this field is also very important, and there is another field, that is information field, that is user informations. Okay, and this information field contains the user data. Okay, so user data is actually present in this field. And after that we have another field, that is FCS field. FCS field, that is a frame check sequence, and this is frame check sequence means what? This is for error handling field, that means it can detect any error. So error detection field. Okay, so this is the error detection field, and after that there is the end of the frame. Again we have a flag field. Okay, so these are the different field structure. So in S frame, that is the supervisory frame, in S frame we only have there's flag, address, control, FCS and flag. Okay, these values are there only in supervisory frame. And in U frame we have another extra frame, that is the management informations, extra field, that is the management informations. Okay, so that means any type of any type of things, any type of suppose I want to send the data, but just now the receiver is busy, so you have to just wait. So this type of management scheme can be here. So whole management informations can be stored in this U frame. Now we can manage the overall network. Okay, so these things can be here. So HDLC frames have, that means 3 different types of different categories of frames. Okay, so now this is the control field format for different frame types. So here you can see that is I frame, S frame and U frame. We have different frame structure, for different frames we have different pattern of control field. Okay, so control field is responsible for what? Control field is responsible for flow control. Okay, so it is responsible for flow control. So here you can see we have the first bit. In case of I frame, it is carrying the user data. I frame is actually carrying the data from the network layer, and they can include flow and error informations. Okay, it can include flow informations or error information. So this is called PG backing. So flow and error control both are happening here, and there are different subfields can be there, and these fields will start from 0. Okay, the first bit of this control field is 0. So this is first bit. Okay, this is the first bit, and which is 0. This means the I frame. So when we have suppose you are a frame is provided to you, and the starting bit is 0, that means you will identify that yes, this bit is I frame, is an I frame. Okay, and if the first bit is, if the first 2 bits is 1 0, then it should be a S frame. If it is 1 1, that means it will be what? It will be a U frame. Okay, so according to the first and second bits positions, you can identify different frames. Okay, so this so we have this field. So at first this is for identifications. The first bit you can identify the frames using the first bit, and the next 3 bits what we have, that is called NS. Here this field is called NS, and this is defines the sequence number of the frame. Okay, so it stores the sequence number of the frames. So here the sequence number can be between 0 to 7. Okay, and after that we have after that we have a P or F field. P or F field means this is actually for dual purpose. This is a single bit, and this is used for dual purpose, and when the bit is 1, that means there can be, the value can be 1 or it can be other than one. Okay, two fields can be there. So this field is P for actually polling. Polling means what? Polling, here the term polling. Polling means what? Polling means, suppose a sender wants to send data to the receiver, then at first sender asks to the receiver whether the receiver is free or not, or the sender must supervise the channel, that whether the channel is occupied or free. Okay. So each and every time when a sender wants to send any data to a receiver, sender needs to check the channel. Okay, and then only if the channel is free, then only sender can send the data. Otherwise, there can be some collisions can be happen. So the sender must do these things repeatedly. So this is called polling. Okay, so there is these things can be there, and so this is for polling means you have to, the sender or receiver, both hosts can be always check the channels, whether the channel is free or not, and sender also always wait for the response of the receiver, that whether the receiver also free or not. So this type of things, this type of signaling is called polling, that always you are checking the things, and the next time also when you are sending the data, you need to check the transmission media, and then only you can send the data. So this is called polling. And F for final, that is the yes, you can send the data. Okay, so this field, this is a single bit field, and it can used for two different purpose. Okay, and final means that is the frame is actually sent from the. So final means that you are sending the data from sender to receiver, and the packet is actually, the frames is actually passing through the media, and it is received by the receiver. So these are the things. So this P by F field, this is also a single bit field. Okay. So each and every frame, that means the control field always each for I frame, S frame and U frame both have these frames, this P or F, this frames is here. Okay. So similarly, and the same for the S frames also, and here the U frame you have the 1 1 as the first fields, and now these are the different codes, it can be here. So different values, different codes can be here, and this is sequence number, and this is a response from the receiver actually, and that means the whether it is acknowledgement or it is the not acknowledgement, these values can be stored here in this field. Okay. So the control field can hold the sequence number as well as the acknowledgement number, and the polling or single bit, there is a single field, this is actually holding the polling, or this is the final, that means polling is going on, or the finally you are sending the data or not. So this type of informations can be there. Okay, and the first field are different for each and every frames. So this is the control field format. Okay, so this is the U frame control command in response. Just study it, and this is, there are different type of codes and what is the meaning of that. Okay, this is not much more important, just this is the U frame control commands. Okay, so now, okay, this is the connections and disconnections from this is the connections and disconnections formats. That means, see how we can establish the connections, and after data transformations we need to release the connections. So at first you have to establish the connections. Okay, so the node A and node B is here, and you want to just communicate with node A to node B. So in that case, if it is a U frame, then what is going on, then see, this is the flag value, and there is also flag value FCS control, and these are the values, different values can be here. Y11 means this is a U frame. Okay, YY means this is a U frame, you are sending the U frame. So U frame is sending the data, and so before sending the data the connections must be established, and after that the receiver need to send the acknowledgement to the node A also. Okay, so same thing is after that you have to release the connections. Okay, so this is the connections release, this is the second step, and after the establishments, after the means data processing is over, data transformations is over, then you need to just disconnect the connections. Okay, so this is the simple thing, and this is the PG backing without error. That means here you can, in case of PG backing, you can send, suppose I am sending a iframe, node A is sending a iframe, and node A begins the exchange of informations here with the iframe, so the number should be 0. Okay, so first frames this is 0, and it can be followed by another frames, and it can be 1, data frame 0 and data frame 1. Okay, so two values can be passing here. So the sequence number can be different, the first one is 0 and second one is 1. Okay, so PG backing means what? You need to pass the sequence number also, and for the receiver end you need to pass the acknowledgement also. Okay, so this is the PG backing. So if this pictures is actually producing in your exam, then you can so that is the diagram of PG backing. That is, here you can send the sequence number as well as the sequence number you need to send, and as well as the receiver, from the receiver end there should be an acknowledgement number can be sent. So this 0 is for iframe. Okay, this is the first field, this is for iframe, and the second field is 0 and here is 1. Okay, so this is the frame 0 and this is frame 1, and there is the first frame, that is the 0th frame you are passing. So that means you need to need the acknowledgement of the 0th frame, so that must be passed to the sender, and this is the data part, and this is FCS, and this is flag. And from the sender side, when these two frames are received, then sender needs to access the second frame, so the 2 should be the acknowledgement number. Okay, so this is for frame 0 and this is for frame 1, so they can receive the next frame what the receiver wants to, that is the second frame. Okay, so this is the acknowledgement number. Yes, so 0 and 1 is accepted, and now send me the second frame, so it can be passed. So here in this way the whole thing is going on. That means PG backing without error means you are sending the informations, whatever the informations you are sending through the frames, all the informations correctly can be received by the receiver. Okay. And this is the okay. Okay, so this is the PG backing with error. PG backing with error means you can send the NAC number also. This is NAC. If there is any rejections is going on, suppose this frames is passing, the acknowledgement is passing from node B to node A, but they are lost. This data is lost here. The frame is lost here. In that case, what will happen? The receiver wants to the frames. Actually, data frame 1 is lost. Okay, so if data frame 2 is passing here, so it should be discarded, and in node A sending the NAC to node B. Okay, so that is so this is the rejections field. So the field is actually indicates that the frame is not accepted, so not acknowledged. Okay, so not acknowledgement is sent to node B, and then that must be resent to the receiver. It must be resent to the receiver again. Okay, and after that data frame 2 can be passed. Again data frame 2 needs to resent and it will be accepted. Okay, so this is piggybacking with error. That means if there is any frames lost, then that frame needs to, that not acknowledgement needs to send by the receiver to the sender, and after that sender needs to send the data again. Okay. So, this is the piggybacking with error, and piggybacking without error means you are sending the acknowledgement that yes, the data is accepted.